Welcome back, guys. We are coming to the end of our tutorial series, but we have some important things to still hit. Today, we're talking about state machines.
We still have a lot we want to get done in the final episodes here. So for that reason, we are going to speed things up a bit.
And that involves me not being in the driver's seat because Nick is far superior when it comes to coding techniques. We're going to be covering some theory, but we're also going to be typing out code as well. And I think we just both agreed that it might be a little bit faster and cleaner for Nick to drive and me take the passenger princess seat. Yeah, and I'm here to make sure Nick speaks common man's English through this very technical process we're getting into.
Yeah.
A quick note about this episode from the noob here. I don't know if I'd recommend completely following along the first time watching through this episode. There's going to be a lot of deep concepts that I feel like you should fully understand before you just type whatever Nick is. I have a feeling that as a viewer, you'd want to open up the companion page just in case we missay anything or miss a detail. Nick usually does a good job of adding any extra notes there to follow along with ease. But the code we're going to use this episode is what we're going to be using the rest of this tutorial series. So you are going to want to match it by the end of this, but just letting you know, it's going to get into deeper concepts and you might not want to just copy and paste right away.
So state machines. State machines, you've probably heard about them by this point. We've talked about them. Every game dev on the planet harps on them. And then of course, there's, God, how many definitions of them out there, especially on Wikipedia?
Can I guess what it is off the rip?
Go for it.
Because I still don't really know what state machines are. I feel like state machines are like systems you set up in code that work with each other, kind of like something in an animation system that would be like, I'm currently running, so I can't be walking at the same time.
Yes. That's
Very
largely the goal. Yeah, it's like you're able to kind of isolate functionality or behavior or whatever into what we call states, and then you can kind of control what other states you can access from whatever state you're in.
So it could also be used in something like this room, this door is locked. So
Yeah.
that is the state that it's in. And so I need to have a key to do it. And like that would be kind of like a part of a state machine.
Absolutely. I mean, a door could itself be a state machine of, it's locked, it's closed, and it's open, right?
So I could be a state machine. Everything could be a state
Everything
machine.
can be a state machine. Absolutely. So let's visualize this a little bit, and we're going to use a tool for that. And so that way we can kind of talk about the theory of it, have something more visual before we jump into the code version. And before anyone asks, this tool is called Excalidraw. It just runs in your browser. You can go find it and do it for whatever planning you want to use it for.
I could not think of a nerdier name to name a
Oh,
technology.
absolutely. What I have here is our first state. So think of this as our character state machine, and the machine would be all of the possible states and things it can do. Now, there's a lot of classifications of state machines. The one that most people are talking about would be called a finite state machine or an FSM. That just means that you're typically in a state at a time. There's also ones where you can have hierarchies of states or stacks of states or states that run all at the same time. We're not dealing with any of that. We're dealing with the most simple form because that's all our little hero character needs.
Basically like a system that says like, it's either this or that.
Yep. You can only be in a state at a time.
Okay. Not necessarily binary, but just like options, and it can select those options.
Yep. Now, if you're building like a first-person shooter or something where it's like, I want to be able to like run or slide or whatever and also reload my gun, then you might want like a dual state machine where it's like you have an upper body state and a lower body state. But then that gets complicated because what if you're climbing a ladder? Well, that's like a whole body state. So now you got to turn off the other two state machines or one of the state machines and then have like a state machine just for like climbing the ladder. And then when you get to the top, it's like, oh, pull your gun back out. Now you can be the two state machines again.
And then there's a state machine for all three of those state machines.
Sometimes, and that gets into the hierarchical state machine stuff. Again, not dealing with that here. We're going to keep it real simple. A state machine is also not just for animations. So like in Godot or Unity or Unreal, you'll often see some kind of an animation state machine. It's going to look like this. And we're going to be modeling the same kind of thing over in Excalidraw for our theory purposes. But a state machine does not have to be limited to animation at all. So now we're kind of looking at the machine of states for our character. And right now we have one state, which is idle. So they're just standing there, breathing, looking around. We can easily add more states, like what to do when they're walking or what to do when they're running. You might want to have things like an idle check state. That's when they're like kind of looking around the room or fidgeting or adjusting. So to move between these states, we have something called transitions. I personally don't like this word for moving between states, even though it's correct. I don't like the word transitions because there's a lot of things in a state machine where like a transition is itself a state. For example, think about how many things involve an animation of like, I'm about to climb a ladder. Well, when you're entering into the ladder state or the climbing state, you're going to have some kind of animation where your guy puts his hands on the rungs, right?
Like grabbing ladder state.
Yeah. And then as you start climbing up or down, those will be states. And then when you get to the top and like mantle over the edge, that's another state. But if you think of a state machine too literally in terms of states and transitions, you might think of those like moving from this state to this state as just a transition. But there's usually like states in between that are the transitions. So when I think of a transition, for example, going from idle to walking, what this really is a condition. It's something that's going to cause that state change to happen. And so in the case of moving from idle to walking, we would say, well, we're currently on the ground, and that's going to be an important distinction later for some other states we'll get into. And our character's speed is not 0. We're above 0 speed.
To start walking.
To start walking, yeah. And just like with going from idle to walking, we would say, hey, we would go from walking to running when we're on the ground and our speed is greater than whatever our walk
5
to run speed happens to be. 5, yeah. And we've already kind of seen this. Like we've more or less implemented a state machine with our conditions, but the challenge is if we were to keep going down that path, which originally we had planned of making a very messy player character and then introducing state machines to clean things up, but if we had just kept going with that plan, we would suddenly have this very complex if chain that would be very sensitive to changes, where we could easily introduce all sorts of crazy bugs and, oh, well, now that I added this state that the character can be in, I have to consider that from this one, and it just becomes a mess really, really fast. Especially when you start considering all of the different conditions or transitions that can occur between like going back from walking to idle where we're on the ground and our speed goes back to 0, or from running back to walking. And you will often see game designers at big studios start by creating these big graphs of character states and behaviors modeled in a tool like this, where they're trying to consider all the different animation parts they might need or all the different things that they have to account for when they begin coding. But one of the beautiful things about a state machine is if you have a great state machine kind of code architecture set up, you can very easily add these things onto the system after the fact, but you need to understand what you might need in the game, and this is a great way to figure that out.
I feel like it's a little bit like having, when I make a YouTube video, I have images, gameplay, videos I pull from the internet, and my actual camera recording. And yes, I could put everything into like one folder and just like go through it. But if I just had separate out things like I want a new image in my video, I can just go to an images folder instead. Like it's a state machine is a way of organizing.
Yes, absolutely. That's the main thing it offers. It's a way of organizing code into discrete chunks where how I get from one state to another is super clear. You can see how this gets pretty complicated pretty quickly, where it's like, hey, we're going to be standing still for a minute in the idle state, but maybe after like 5 seconds of doing nothing, we go to idle check. And then what this does is this says, hey, after I've been playing the idle check animation, so my animation finished, we're going to go back to our idle state, right?
Yep.
So that's what we're going to kind of be building the code for in today's episode, is something that lets us model all this sort of behavior. And at some point, I'll probably just let you start telling me what kind of states to add.
Yeah, I think it'll be interesting to see this like visualized out in code, because this has boxes and lines, but in
you're not going to have that.
We're just going to have to use words and imagination.
Yeah. So we are back in our Godot project. We are in our player scene. And just like there are many types of state machines and how state machines can work, there's also a lot of ways you can code up a state machine. The approach I'm going to show today is a balance of nice to work with, but also performant, or at least as performant as we're going to get in Godot with the scripting language.
Oh my gosh, here he goes again.
So we are going to start by building a state machine specific to our player, just to keep it simple. You could build a very general state machine machine that could work with any character type in your game, but that often adds a lot of complexity to the planning and architecture process. So when you're first starting out, don't be afraid of a little copy paste code reuse. We're going to build a state machine for our player, and then eventually when we get into the enemies and combat, which should be next episode, then we'll make a state machine for the enemies. So we're going to start by creating a script, and this script is actually going to be a base class or a base script that all of our other states are going to extend from. So just like so far we've been extending all of the nodes that Godot gives us, we are going to make a script that all of our player state nodes are going to extend.
So is this going to be something that's global, like in the background? Like we're not going to like throw this into a scene. It'll probably just be like in all of our scenes.
It's going to be a little weirder than that, and you're going to have to bear with me. I'm going to introduce a few new things on the way to this.
Why do I feel like the word ethereal is going to come up?
That's not incorrect.
Omnipotent.
So what we're going to do is I'm actually going to make a folder for our new player states just to keep them kind of organized in one spot. So under our scripts folder, I'll just make a player states folder. And then inside this folder, we're going to make base player state.
By the way, this isn't cutting. Look at how much faster Nick is at typing than me. Keep going. we have to cut around so much of my typing.
Hey, I've been doing this since I was 9, and just this basically.
Just always bringing your age into it. We get it. You're 100 years old.
Okay, so we'll create that, and we will open it up. So a lot of Godot tutorials, when they cover state machines, are going to make a node for each state. We're not going to do that. The reason we're not going to do that is because nodes come with some overhead. Yes, it's nice to see a node for every state under your guy, but it's a lot more to manage. Yep. It's honestly more code at the end of the day. It's honestly not super performant. So we're going to avoid that. Instead, what we're going to do is we're going to extend the base class that nodes extend, which is called ref counted. I'm not going to teach you what ref counting means. If you want to learn all about the memory intrinsics, I can't say that word.
I can barely say ref counted. I'm terrified right now. I think a lot of people are going to be terrified when we brought up ref counted. I feel like I'm in back rooms right now.
All you need to know is this is just kind of a generic class we get to use and make.
Okay. And it usually all nodes extend from this?
Yes, all nodes extend
So we're almost making a custom node?
Kinda, yeah.
Okay.
So we are going to get rid of all the classes that come with it because we're going to be defining all of our own kind of ready classes. The other thing we're going to do is, we talked about this last episode, I think, but we're going to add a class name keyword up at the top. And this lets us access this script we're making, or the type of this script we're making, by a keyword.
Hold up. Don't listen to what he just said. What Nick meant to say was by a custom, globally accessible name.
The keyword here is going to be base player state. Oh my God.
So is this going to be, does the class name make it like where we can add it to the scene now too?
No.
Like in that menu?
So we can't add this to the scene because it doesn't extend a node.
So that's what I meant by like potentially ethereal coming up, is like this is outside of nodes. This is outside of
we're doing some real custom stuff.
Who has been excited about this?
So we have to put the machine itself somewhere. There's something that's running this code because it's not the scene itself, right? It's not, these aren't nodes. So just like a node has a ready function, we are going to want a function that we can kind of run when we first enter the state. So if we go from idle to walking, maybe the walking state wants to do some stuff when we enter into it, and we call it entering. So we're going to make a function called enter, and it's going to not return anything. So if I can type, as after you brag about me typing earlier.
Still faster.
So we're going to have a function called enter, and I'll put a comment above it, called when we first enter this state. Okay. Just like we have an enter, so we can execute some code when we first enter the state. Whatever state we're leaving, so the idle state that we're about to leave to go into the new walking state, maybe it wants to clean up some stuff after it's done. So we'll call that exiting a state. So called.
I thought for a second you'd be like, obviously it should be called cleaning, and I'm like,
you can call it cleaning.
I was expecting exit.
All right. And again, I'm just putting pass in here so we can kind of leave it blank.
Not get big red lines.
Yeah, or just not compile at all or run at all. And then what we need now is every single physics tick or physics frame that we are in this state, we might want to do some logic. And we're just going to call that the update. So called for every physics frame that we're in this state.
I thought you would call it like function physics process.
We could call it physics process if we want. It's just saying that while we're in this state, we're going to do some kind of work.
Because that's what's been described as like something that's happening every physics frame so far is physics process.
I mean, we could also just call it process.
Does process every physics frame though? I thought process
technically, because that's when we do our game logic. It's just saying that we're updating during game logic.
Update. I feel like we should get more comfortable with update. I feel like there's a lot of functions called update, right?
Yeah, and we will take in our delta time because there's a lot of things you might want to use delta time for in your state machine.
If you don't use delta in this function, does that break anything, or is this kind of like it'll give you a warning or whatever, like saying like you didn't use delta in your...
It'll just give you a warning. So this is our base player state. So now we're going to set up the actual state machine part. And because we're building states specific to the player system, this is actually going to go in our player script. What I'm going to do is I'm actually going to just add a little space in here, and we're going to say the current state that our player is in. And this is just going to be a variable or property, and we'll just call this state. And we're going to reference our base player state class. And by default, it's going to be nothing, which we can explicitly set to null just to be super clear that there's nothing there when we first start. And we can always change this in a minute. So what we're about to do is all of this code we have in physics process belongs in our state machine, in our states of our player. And so we're about to do the first bit of a process called refactoring, which sounds scary. It just means, hey, you learned some new things about what your project needs to do or what your code needs to do. So now you got to rework some stuff. And this happens super often in code. Don't be scared about refactoring. It's just a natural part of software development and game development.
Prove it. I'm scared still.
Okay. Every single physics process, we are going to call.
See, that's why I'm like, why wouldn't we name this the same? Why are we naming it update if, like, you know?
It's more about the purpose of what's happening. It's not.
Okay.
Physics process is very descriptive at this lower level kind of script node thing. But as far as our state's concerned, what it's just doing is updating game logic.
Okay. Oh, sorry. Let me say okay again that Donna, you can edit me not yawning. Okay. Very serious. Okay.
All right. So because state is null, if we were to just say state dot update delta, which is the function we need to run, we would get an error because you can't call update on nothing, and null is currently nothing. So what I'm going to do is just say, hey, if state is not null, then update.
By the way, the bang or the exclamation point equals, isn't that the equal sign with a line through it usually?
Yeah, if you're using font ligatures in another editor, you will sometimes see this in a very weird format. So this is all well and good, but not very interesting right now. So let's add our first custom state, which is going to be the idle state. So we'll say idle player state.
So you're adding this to your player states folder, making a new script in your player states folder.
Yep, and you can see it down there. So we'll open this up, and instead of extending node, we want to actually extend our base player state class, and we are going to give this a custom class name, and we'll call it idle player state, and we can get rid of these. And we don't really need this to do anything right now. But if we wanted to hook into enter, wanted to hook into exit, and we will be seeing this in a moment, then we could, define those functions again here. We could also just very easily copy paste them just to have them ready. So we could go like this and then fill them in once we have code for them. So sadly, Godot's not going to have a template ready for us because it's not something they offer. We're doing something completely custom here. But there's one critical thing before we do that I forgot to add. Especially when we get into enemies and NPCs, we don't want to have to make instances of these classes every single time for performance reasons. There's no reason to have to do that. And it's also going to plug into how we use these states in a minute. So we are actually going to take in a reference to our player script from these states. And for that, we now need to go add at the top of our player script the player class name. So by putting this here, we can now reference player, the script.
Okay. Does that change anything with like the logic of the player adding that class name right there? Like,
Nope.
For instance, isn't player a node though as well? So now could you add player if you just define its class name in the scene import menu?
It didn't change any logic. It just means that we can reference player as a type like this. That's all it did.
Okay.
the player state still isn't going to show up in the scene because it's not a node. So like I don't.
Yeah, I wasn't questioning that. It's more of a question of the fact that we are messing with player, and I'm wondering, like, if you were to hit that plus button right now, would you see, now that you added a class name to it, would you see it in there?
Yes, you actually would.
Okay.
So if I did player, you can see here now there is actually a player script showing up.
Just thinking 2 steps ahead is all, not a big deal.
Yeah.
Keep going.
Good
Probably
catch.
threw off the lesson. I apologize.
No, you're good. So basically, we want to hand the player instance that we care about, or eventually the enemy instance we care about, or whatever, to the state class on each of these functions. And then what that lets us do is when we make these states, which we're about to make instances of them, meaning we're going to use this as a blueprint to make something, we can share the same instance. We can only have one instance in memory that can work with any player, any enemy, any whatever, by just passing it in. And that'll make more sense, again, a little bit later in the series. Okay, so I'm going to just repeat that for exit. We'll pass in player here, and I'll copy paste it, and we're going to do it as well for update. So now if I head back to player, we're going to have a problem here because state.update is now expecting the player, and this is where we can use that self keyword we talked about in a previous episode, where self refers to the instance of the script that we're in. So self is the current player node that this code's running on. So now we need a way to kind of set up our idle player state. So we want to say, hey, they're idle. Where does that live? Where do we put that? How do we make a base player state class? How do we make one of these? I can't hit the plus button. We could actually say idle player state, and we can do this because we did the class name at the top of the file, and we can say .new. And what that says is, hey, go make me a new instance of this class. And because we now never have the concept of null, because we'll just make a hard rule that we should never not have a state. That's a...
Yeah, like you're either going to be walking or running.
Yeah, you should always be in a state. Because of that, we can actually get rid of this check, which is a nice little tiny performance boost.
Little milli nanosecond.
Yeah. So this is cool if we were to try running the game. If we try running the game, there's no difference because the idle state doesn't do anything. But hey,
yeah,
we've got it set up. We've started the process.
Code is satisfying.
Oh, yes. So let's start moving our code into our states.
Something that's a little confusing to me is jumping between each code that, like, they're almost like chained together. Mm-hmm. That gets like a little fuzzy in my head when we're like, for instance, you were talking about instancing. I don't really know the difference. Like right now I think of instancing as like, there's something over here in its own scene or something, and an instance of it is when it jumps over to the other scene, but the original is back there. So we're dealing with something that's like a new version of the original.
A class is like a blueprint. A script is like a blueprint. It's telling us how to construct something. And an instance is like the actual construction of that thing. So if like a class is a blueprint for a house, an instance is the actual house we created with the blueprint.
Okay. I think we could actually think of that as like when we have the original scene of a player, even though like the character is in there, all that kind of stuff, it's not really existing until it's in the game when it's instanced in the level that you're in.
Bingo. Perfect explanation.
And the class names, like we're defining like each player state is its own like script that we're gonna like add to.
Yep.
And each one is gonna have a function enter, function exit, and then function intern, whatever the stuff that goes on inside the function or inside the state as its own separate functions.
Yep, exactly.
I think the part that's a little fuzzy to me is once you connect it to the player. Like, for instance, could I have idle player and base player states go to like an enemy, or they're going to need, like, even if they're doing generally the same thing, like a walk run idle, like, could you have something that is more general use, or it's like we're just naming them for the player because we're just kind of focusing on the player right now?
You can totally make a more general purpose state machine. It's just more planning. And it's a lot more consideration and requires a little bit more of a deeper knowledge of code than what we're trying to like accomplish with this version.
Yeah, you're calling me not deep. Keep going.
But that's entirely possible. And you will see a lot of studios do that kind of stuff too.
Okay. Before you remember where we're at, just like to create the script or whatever, you can cancel that for a second. I just wanted to see, like, what did we add? Like, highlight what we added.
So far in our player script, we added state.update, which is calling the other thing we added, which is the current state of the player.
Okay, so that state update self line is basically every second, that's what's checking what state am I currently in?
The state.update is saying, hey, whatever state I'm currently in, I want it to be in control of what the player is doing. So the stuff that the player can do is entirely controlled by the player's states in its state machine.
So almost like, I feel like there's a lot of code that we do where, for instance, even though we're in player, the state switching, is that going to happen in this script or is that going to happen in another script? I have a feeling it's going to happen here, but it's only going to be like a couple lines like of the switching.
It's
like
a little bit of both.
Available.
It's a little bit of both,
okay.
Because yes, the player is in charge of like saying, hey, I'm exiting this state, so call its exit function. And then I'm entering this state, so call its enter function. And then the states themselves will be in charge of determining what states you can go to. Now, there are exceptions to that rule, and we will extend our state machine to account for those.
So you're basically saying like in idle state, there's going to be a list of options basically that we say of like where it can go to next inside of idle.
Yep.
So we can call them from here when we're referencing idle.
Yep. So let's quickly just add we'll call it change state. It's just going to be a function. Okay. And we'll say func change state 2. And we'll take in the next state. And the type should be a base player state. Okay. Before we move into the next state, we need to make sure that our current state exits. So at that point, we'll say, hey, state, as in the current state we're in, that state should exit. And we just need to pass it ourselves, because remember, it needs the current player instance passed in. Then we can say, hey, state is now changing to the next state. So now if we were passing in like the run state, then we're not pointing at the idle state anymore. We're pointing at the run state. So state represents running.
This is where I feel like coding kind of does make sense, where this is literally like its order of operations.
Yep.
So we're just like, we exit it first, then we go to the next state. Like if we flipped around 19 and 18, this wouldn't work right.
Correct. Yeah. And then what we're going to do is we'll just say state enter, because now state is running. So we want to tell the running state, hey, you're up. Okay, so that's covering our change state 2 function. And we'll just add a little doc comment here that says changes the current player state and runs the correct functions.
And just a reminder, if you guys remember, 2 hashtags is making it documents. So if you use the function later somewhere and like your partner in game dev is working on it, it'll allow it to, you scroll over, change state 2.
Now if I hover over this,
see the definition for it.
Yeah, there it goes.
Yeah, now you get a definition like on the fly.
Yep. This also brings up a good thing that we're going to want to do of like when the player first comes into the scene, what if you don't necessarily have idle player state as your first state, Or maybe the idle player state needs to reset some stuff when you first enter it, right? Like the timer for when to go to the idle check or something like that. For that reason, we actually want to add our ready function to player.
That's what I was going to ask earlier when you said our first thing. I think it was like physics process, and I was wondering that like before we do an update, is there a thing that's just like you have the thing there? Because ready only activates when it's in the scene.
Yeah, when it's first added to the scene.
Added to the scene, but not necessarily appearing.
So we'll say state.enter self, and we don't need to worry about exiting the last state because it's the first time any of the states are like running on our character, and so that just kind of sets up like our idle state or whatever for first time enter.
So that's ready. And like, does that basically mean like that's there, but then like almost instantly it's going to change state to how is it selecting idle after this ready? Have we gotten there yet?
We haven't gotten there yet. So we're about to move a bunch of our code into other states, the states that they belong in.
So is our player.gd script about to be like a state manager? Like it's going to be a lot more bare bones, like higher up stuff?
Yep. Let's just quickly scaffold out the kind of states we're going to need. So let's think about what our player can do so far. So they can stand there. They can walk.
They can...
What else can they do?
I was going to say they can loiter.
Loiter? Yeah, they can stand or loiter. They can walk. They can run. They can fall. They can jump. Eventually, we're going to have things like rolling, swinging a sword, getting hit, because getting hit can be a state. If you think about Link or Blink doubling over in pain when he gets hit by something. Yeah. And you can kind of see how this might start to clean this up, where it's like, okay, we have a bunch of code up here, and then we have a bunch of like, oh, well, if this is true, then do this thing. And then we have a bunch of code down here that's also doing stuff, because we're going to really dissect this and break this apart and put it into different states that just kind of do that one thing. So we're going to just quickly start adding the walk state, the falling state, and the run state, so we can kind of blitz through these. In fact, one trick is I can just take my idle state here, and I'll duplicate it, and just call it walk player state. We'll go into it. We'll just say walk, save, and then we will duplicate that, and we'll say run player state. Thrilling, I know. The most exciting thing ever.
I've noticed that when I'm doing stuff in Blender and like organizing stuff, I've been doing the reverse of what you're doing, where it's like you say player state then the thing. So you can, like, if you do alphabetize, you see the thing it's grouped under first. Yeah, do you ever think about that?
I actually do that for some things myself. So what we'll do is I think we can just kind of like take all of our code currently in our physics process function, aside from the line we added, and we will just paste that right into idle state under the update function to start. Player. Delta, float, void, there.
Real quick, if you were to go to like fall player state, does it still say class name idle player state right now?
No, so I went through and renamed all of these.
Okay.
I actually called it falling. You could just do fall. Like, it's totally up to you. You have complete control.
Yeah.
And you'll also notice that this does not have to match the thing over here. So I did that in idle. There we go. All right, so we moved everything over, and everything is mad at us because if you remember, all of these things are on player. So the first thing we would do to fix this kind of stuff is just say player dot, because player is the player instance that we want to know is on floor or not. And player is where velocity is.
Is this refactoring?
This is all refactoring, baby. Now, I don't have to do it with delta, because delta is a parameter that's being passed in. So we're getting that variable from the outer function. So right off the bat, we now need to start talking about where the transitions live. How do we go from idle state to falling state? Because if we're in the idle state, and suddenly we're not on the floor anymore, we're not idling anymore, we're falling.
Yeah.
And we could totally stay just in update and do this kind of thing. But personally, one of the challenges I find with that is then we are always delayed by one frame, like one physics frame. Because if you use our idle update here to start falling, then it's not until the next physics frame that the falling actually starts happening, right? So what I like to do is I will add one more function. We'll just say called before update is called allows for state changes.
Okay.
And we can just call it like, you can call it like pre-update is a good name. You could call it something like determine next state. Call it whatever you want. It doesn't matter. It's up to you. Whatever makes the most sense for your brain. And all we need to do is we would just literally call this before our update. And that just lets you kind of split the code into two parts. One function, whoops, I don't need the delta, that's my bad. One function is just to determine what should our next state be? Do we need to be in a different state before we start updating based on the state? And then the function after is what we actually do when we're in that state.
Okay.
So now if we go back to our idle player state, we can add our pre-update function. Oh my God. And so what we can do is we can say in our pre-update, if we're not on the floor, well, now we need to like go to falling state.
Why did to-do just highlight?
So to-do is a common pattern in programming in comments. And because of that, a lot of editors, or if it's not built into the editor, there's usually extensions and plugins to do this. But a lot of editors will highlight the word to-do to kind of like make it show up as like, hey, this is something to be done.
I'm wondering is there a problem with managers or whatever, or probably project managers that like add to-dos in places that it's not the place to do the to-do?
Yes.
I imagine, because I'm just thinking of like if I were to like give you a reminder of like, hey, we're working on this thing, I'm just like, I just have a feeling I like always keep it at the top because it's just like it's probably somewhere in here.
This is actually a really handy pattern, and I actually will often start my like larger, more complicated functions and tasks and whatever by saying like, what am I trying to accomplish? Because by saying, hey, to do this, to do this, to do this, and breaking it down to parts, I can think through the problem before I commit to writing the actual code.
Is that stubbing or is that scaffolding?
Yeah, that's a type of stubbing or scaffolding for sure.
Stubbing and scaffolding the same thing?
Kind of, yeah. I'm sure there's some semantic difference that someone in the comments can harp on me about.
Flamed.
Just flamed. All right, so at this point, what we could do is we could say player change state to, and then just like how we made the idle state, we could say, hey, the fall state dot new. So that's creating an instance of the fall state, and we're telling our player, hey, go to that state. So then the next thing that will happen is the exit function, if we had one, on our idle player state would run, and then the state would change. The fall player state's enter function would run, which we will be making in a moment. And then after that, the update function for the fall player state would run. So there's a lot of stuff that happens that's very easy to kind of reason about of like, hey, when I go into the fall state, this stuff should happen. When I'm in the fall state, this stuff should happen. And so you get this very powerful, flexible system.
Do you always start with fall?
You don't necessarily start with fall. Like, for example, if you're jumping up, you might start with the jump state. And then only when you hit the apex of the jump, when you start falling, then you might transition into a fall state, right?
But I'm saying, why are we choosing fall here?
To keep it simple for now.
Okay.
We'll make it more complicated later. Don't worry. Now, this brings up something that I called out earlier. Creating a bunch of instances of states isn't great for performance. And we've already designed it where we could have a single instance that takes in everything it needs and could be shared and reused across everything. So what if we only had to make an instance of every state one time and store it somewhere? We're going to make a script called player states that is all of the player states just ready to go.
I thought this would just be on player then.
If you did it on player, you would be making an instance for every state belonging to that player. And depending on how you want to architect your game, you could totally do that. But because I am a
autistic person.
Not inaccurate. Because I am an autistic person, I want every ounce of tiny performance improvement I can get. And so I would rather just have one instance for these things that we could share and reuse across everything.
My fear is going to be I'm going to get confused about where to do stuff in player and where to do stuff in player states. When you build it out, it'll probably be more clear.
Yeah, and that's a totally understandable fear. I get why you'd feel that way. It should
like
clear
when
up.
I was doing rigging stuff with the animation stuff, and there was bone groups, and I'm like, what goes to mech and what goes to control and what goes to def, and like some overlap, like and all that. I was like, that's what I fear is coming here.
It's one of those things, though, like even with like what you just said with Blender, where the more you kind of spend time with it and get used to it, it starts to click and you're like, oh, I get why all these things exist.
Yeah, I think, so basically with the player states, and I might be repeating you, is this going to be a place that we can reference instead of having to reference like fall and idle and all that kind of stuff?
Mm-hmm.
So in player, we're going to be referencing player states that references each individual state machine.
Yes.
Which is its own script.
And that's kind of what this is here. We can say, hey, var idle, and I'm using the capital lettering here so it looks like a constant. Unfortunately, when you make instances of things, they can't actually be constants because constants can only be like simple types like numbers and stuff like that, at least in Godot. And so for that reason, this is something that could actually be changed later. It's not a proper constant, but we're going to be using it like a constant. So I'm using the naming
it's almost
convention.
Like a semantic. It's just telling you like it's not going to change.
Yes, please don't change this and treat it like a constant. Just like before, we said, hey, idle player state dot new when we were first setting up our player state. We're going to do the same thing here. So we're going to say idle player state dot new. And now we need a way to access this set of states from ideally anywhere, right? Like this is on a node and I did that intentionally. How the heck do I get this single instance of state from anywhere in our game? And so for that, we're going to introduce a new thing that's going to come up a lot as you make your game, which is if you go into your project settings in Godot, you can go to this tab called globals.
I knew it. Okay.
Yeah. And if you're in a lot of other programming languages where you can have like a global version of a class where there's only one version of that class or whatever, you'd hear it called a singleton, and technically Godot still calls it that too. So if you see the word singleton, it just means a global class where there's only one and you can access it anywhere.
I think the ways I've seen it used, and I feel like we've even used it in our game, is the player.
You can use it for your player. That's one way you could totally do it, because in Godot, a global doesn't just have to be a script. It can actually be an entire scene. In this case, we're just going to do a script. So I'm going to use this little folder icon here, and we'll go into scripts, and we'll go to player states, and then we will go to player states, right? So that's the script. And then we want to access it under whatever name this is. So I'm going to just leave this as player states like that. hit add. And now we have this global that the moment our game starts up, Godot is going to go create this node and script and everything. Or if it was a scene, it would go create that scene. And then what's really cool is now if we go back to our player script and we remove this idle player state.new right here, and we say player states dot, we can see that we have access to our idle state. And so this player states will hold all of our state instances. That way there's one of all of those. And then there's one player states kind of container, I guess we'll call it. And then we can just access each of the states off of it. And so when we want to change, from this state to our falling state, for example, over an
By
idle.
the way, this makes it so the globals, you only need one global player state instead of like having a global for all those.
Correct. And so now what we can do is let's just quickly add our fall state here. So we'll say falling, fall player state dot new. I guess we'll call it fall. You can use the ing suffix if you want, or however you want to like phrase it. So we'll add that. And then if we go back to our idle player state, now instead of having to create our player state on the fly, we can just use the same one from our player states global. All right, it's been a few days now. We did take a break. This is a long one.
We needed it. Our brains are ready and primed to go. Didn't just take a nap.
So we'll go back to our idle player state class where we pasted all of the code we're about to refactor. The first thing I think we want to do is let's add our enter function to our idle state. Mm-hmm. And so the reason I'm adding this enter state is we can use enter to kind of do actions that should happen the moment we first go into that state, rather than having to do some actions over and over and over while we're in the state.
Almost like a ready function.
Yeah, exactly. And so the only thing we really need to do, I think, is take our anim tree set function where we set our animation tree to go to its idle state. We can just cut that code and we'll just move it up here and we'll put it right here in enter. So when we come into the idle state, it'll say, okay, I'm going to run the code in the enter function. That sets our animation to match kind of our code state machine. Then
it just makes sense that our animation for idle, when we're entering idle state, is idle.
And this is maybe a good next step to do of just let's find all these different animation things and we can just quickly cut and paste them into their new homes across the other states.
So exactly what we did with idle, where it's like run is run animation, walk is walk animation.
Exactly. Yeah. And then this is going to bring up a good opportunity to start moving some code that will live on our player that we want to maybe share across all the states. So our player kind of holds the data, like all the information about what they're doing, how long they've been doing it, what they want to do. And then our states are the thing that just take that information and then do something based on it.
So basically the player script holds the player state scripts.
Mm-hmm.
Am I semantically saying that correct?
Yeah.
Like, for instance, player states is probably not going to be like put on enemy states, or is it where to like sense something is like sensing that like the character's running?
What we'll do is with enemies, we'll create an enemy states global, just like we have a player states global. And instead of taking in player, like our player states do, the enemy states will take in the enemy that they want to modify.
Okay. The thing I was trying to say about the player states is like, would we ever put player states in an enemy's script?
No, they can ask what state the player's in.
That's what I was kind of wondering.
Oh, yes. They can
do that through the global, not like actually.
Yeah. When we get into the enemy state machine stuff, we'll start talking about a concept called blackboards, which are just basically a big pool of global variables you might want to access from anywhere. And one of those things will be the player. So that way enemies can ask, where the heck is the player? Or just give me the player. And then they'll use that for things like, how close is the player? Should I start chasing them? How much health do they have? That kind of stuff. So what we'll do is we will just take this line. So this is what happens when we're falling. We'll cut that. We will go to our fall player state. We will add our enter function. We'll take in the player instance that we're going to be applying this state to. And then we can just paste the anim tree set here. Now, one problem, and we need to correct this in idle because I forgot to do it there too, is we actually need to say player.anim tree because player is what actually has the anim tree. We are not extending player here, so we can't just say anim tree. It's coming from this object.
Does that go with the same with when you say player on the function of enter? Is our fall player state ever not going to be referencing the player? I'm surprised that we do have to add it there. Why do we have to reference the player there?
Because we're trying to make it where we we can have a single instance of each state that's loaded into the globals rather than having to create them on the fly or create them per player object. On the player object, it's less important to do it this way. However, when you think about enemies, if you have to say, well, and each enemy can be in, 30 states, and then you have to make 30 objects for each enemy. Well, that's going to limit how many enemies you can have until you start to become CPU bound.
Yeah, I think it makes more sense off of the player. I think this is almost just like we're doing this for the player because we're going to be doing it to the rest of the things. But like the player is obviously it's going to be the player.
Yep. The way to think of it is that we're kind of grouping just logic into our states. Funny enough, the properties that we're modifying live on the player or on the enemy, the subject that the states and state machine is relevant to.
Yeah, gotcha.
Okay, awesome. So let's quickly go back to idle. Let's just correct this like that. And keep in mind, this is a parameter. You can name this whatever you want. So if you just wanted to do p and then do p.animtree, you could totally do that, but I would probably still recommend spelling it out.
Yeah.
Okay. So now on this line here, we kind of have our first transition that we have to consider because we can exit out of the idle state whenever our current speed goes, above 0. And we saw that when we were doing the graph in Excalidraw of like, hey, transition from idle to walking when our player speed is above X. So what we'll do is we'll just kind of set this up and then we'll have to correct some things. And this is a lot of what refactoring is you start having to hop around code and know that you're going to put it back together, and you just got to kind of keep that in your head. Or if that's too much to take in, make yourself a little to-do list on like a piece of paper or something. So what we need to do here is we need to kind of take these transitions and put them up in our pre-update, since that's where we're handling switching to other states from this state. There's other ways we could write this. Like you could have it so that you always return to the next state you expect to be in, and that can be a clean way of doing it.
Instead of void?
Yeah.
It's weird to see it not be void.
Yeah.
I feel like I don't even know if I've seen something not after the arrow not be void.
All right, so let's actually take this code and move it up into pre-update, since that's kind of what's happening here is we're switching between our different animation states, which will belong to the state machine. And we already have the if not is on floor. So that's right here. So we can actually just delete that. And then we will cut these states. And the last state else was going to our idle, but that's moved to enter now. So we don't need that here. So I can actually just delete this, and then I'll paste the stuff we cut up here. And now we have a problem because current speed is being calculated in update, or was being calculated in update. So this is where you get into the fact that sometimes in state machines, there's gonna be common code that you need across a bunch of states. And we could just copy paste, hey, get the input direction, turn it into the character direction relative to the camera, and then, get that and whatever. And so this is one of those things where this might be more useful to kind of do once inside a player and assume it's there and then store it somewhere on player and get it back. Or we can create a function that we can call that'll get us this information.
So you mean more of, since its input direction is like gonna live on player, you mean player script. Like you're almost saying like we could put this on player and still reference it in idle player state because it's gonna be connected to player.
Yeah. So what we'll do is let's just go ahead and let's cut lines 31 through 33 right here. So I'll cut those. We'll go to player and let's just make a function called get move input, and it's going to return a vector 3. And I'll just quickly throw a comment on here. Reads the movement input, or I should say reads the directional movement input for the player, adjusts it based on the camera, and returns it.
Real quick, you have 2 lines that have 2 hashtags. Is that like how you continue documentation?
Yep, you can have a comment span multiple lines just by having them directly next to each other.
Yeah, and it's not like making 2 separate entries. It's like that's
nope.
Like so. Is that like a way of like code wrap or word wrapping or whatever?
Yes.
Okay. Basically, like where you instead of write a really long line, you make it readable right there.
Yeah.
By breaking
and
it.
By the way, these lines here that Godot gives you in their editor are kind of suggestions of how long your line should run. It's like ideally somewhere around here. Yeah, and then ideally do not ever go past this. Not a hard rule at all. The reasoning being that some study was done, and when they were picking terminal lengths back in the day, they saw that 80 characters is kind of the ideal range of readability for code.
Interesting. Okay, well, I'm totally going to use that. Keep that in.
Okay, so with this all done, now all we need to do to satisfy it is it says not all code paths return a value. That means that we expect to return vector 3. We're not returning anything. So all we need to do is return direction. And if we head back to idle player state, this actually wants current speed. So we're going to add one more function that's going to get us that information. So then what we can do is we can say returns the player's current speed. And we'll just make get current speed. This is going to be a float. And we can return velocity dot length.
I feel like you're just trying to make a point after I said I've never seen anything after void, after an arrow be void, and like the next two things you typed is like, well, actually vector 3 and a float.
It depends on if you want something out of the function, right? I mean, a lot of the stuff we've been doing is hooking into do code at this stage, but now we're starting to do things where it's like, I don't want to have to like copy paste this code around over and over and over and remember those formulas. And so that's where writing custom functions for this is great. The other way we could do this is you could also do all this calculation in physics process and just simply make these properties on the player. And then that way you're just always doing them before you get into your state machine. So your state can be like, hey, what is this thing? So now what we can do is up here, we'll just quickly say var current speed. And we can say player get current speed. And the next thing we need is we did run speed as a constant just right here. So we need to actually move this up into the state itself. But this run speed probably belongs on the run state because that's what owns the speed. And then we could also just have a speed on walk to know what walk speed is.
And when we like, I'm a little surprised that we're making run speed a const. Like, are we going to be able to like add to that const?
That's a good question to bring up.
Like, as in, like, for instance, if we made our player speed get level up and increase by speed, it's like, do you have your base run speed that triggers the animation, but then you can speed up your guy more with an additional variable or function?
So that's a good thing to bring up. Why don't we move this to player instead? So we'll cut this. We will bring it over to player and we'll set this as speed that the player is considered running. We'll change it to a var and we can just rename it to run speed. Oh my God. There we go. And then back in idle, we can say player.runSpeed. And then that way, if it ever changes via code, or maybe if you want to export it, make a property you can mess with in the editor, this code will reflect that.
Real quick, just as a professional, you have a couple more run speeds in there, I think, or at least one I'm seeing.
Yes,
as
we
you
definitely
just renamed
do.
Run speed.
Yep. So let's just go ahead. We'll copy this.
There's one under your second
right
LF. Yeah.
Okay. So that's making that one happy. The other constant we had is blend speed.
Would blend speed go under player because it affects every state?
Yeah, I think that's a good spot to put that too. And we can leave it a const. So we could just say...
And I even like I'm showing what I said earlier when I was like, a const where you make a blend, like, you know, I think it makes sense for a blend speed to remain the same. When I said constant and then like adding to a variable, I'm like, no. I don't think changing a constant afterwards, I think is you should have a variable. A constant will not change.
Correct. Constant is always that. It's constant.
Yes. So if we wanted to affect the player run speed or like have them slowed or something like that, we do make that a variable, not a constant. Whereas the blend speed between, and I imagine this is like kind of like the transition time.
Yes, this is the crossfade time of the animations. And in the comment I said, default speed, use the blend animations, because it's going to be kind of our default go-to crossfade time or blend time or whatever you want to call it to go from one animation to another. But there might be cases where you want to do a custom blend speed based on I was in this state and now I'm going to this other state and I want to blend those differently.
Yeah, I'm thinking of like if your guy was knocked on the ground and picking himself back up rather than switching from walk to run being much more shorter.
Correct.
So what would you in the future be naming like that, like pickup or whatever, or like self pickup or whatever?
You may not name it anything depending on where it is. Like you may just use a magic number and say it's going to be 0.5, 5 and it's just in this one state file. Because otherwise, if you have to name everything, you're going to be naming a lot of things.
Well, that's what it's been so far as far
Yeah.
as coding goes.
Yep. And as every programmer knows, there's only 2 hard things in programming: cache invalidation, naming things, and counting things accurately.
Nice. I like that.
So now we'll pop back to idle player state. So the next things we need to do is we need to actually move this bit of code over to our run state, since this is what our run state's going to be doing in its update and also when it first enters, right? So what we'll do is we'll just cut this. And instead, what we need to do is tell our player to go to the run state. Because right now we're in idle and we're saying, hey, if all of a sudden we somehow get to like max run speed or whatever we consider run, then we need to go to the run state. So we'll say player.
Would this involve exiting?
Yep, this will trigger the idle's exit function, which we don't currently need to do anything. But if we did, this would trigger the exit function, and then it will trigger the enter function on the run state, and then the run state will do its update instead. So we will say change state to, and we'll say player states. And it's not showing up here because we haven't added there yet, but we'll just type it in as run. We'll go over to player states. We'll say var run, and that is run player state dot new. And I'm just gonna space these out so they're the same. You don't have to do that.
Nice.
Just a formatting thing. And now let's open our run player state. We need to add our enter function. Take in player, give back nothing. We'll paste the code that I cut from the previous file here. We'll update this to say player dot. We also need to update this to say player dot. And then this is going to come from the input direction that we talked about.
Which is on the player script.
It's on the player script.
From
Yep.
input, because it's like every player's going to have the input.
Yep.
Also, right now, just in case we're a little foggy, we're making another player state to our player
Yes.
state. So we have base, idle, now we have run.
Correct. And this is actually going to happen in update, because what this code is doing is this is triggering the lean, like we're doing the lean blends. And so what we could do is we will just say func update. I think the first argument was player. Second argument is delta time. Even if it's not used, you have to put it because we want to allow you to use it in this function. So what this wants is direction, which we're probably going to want anyway because we're going to be using the direction to figure out where to like move the guy if you're running. So we'll say var direction, and we can say player dot get move input, because that's how we were getting direction before. And let's just double check some things here. So if I go back to idle player state, we can see here that we had this bit of code, which was updating our player's velocity using the movement input, the direction of the movement input, right? And so we need to make a function that can take in direction and then actually move the player. And the reason we're going to do that as a function instead of directly in the states is just because we'll use it between walk, we'll use it for run, we might use it for other states down the road. So what we'll do is we will cut this. We'll go back to player and we'll make a new function. This one will be applies velocity based on directional movement input. We'll say move. We'll just call it move. Direction, and that's a vector 3. It's going to return nothing. We can paste our code. There you go. That's kind of all it's doing.
See, I'm surprised that it brings back void. I mean, I guess direction is a vector 3, but I was like, it doesn't give back a vector 3.
Correct. It's not giving back anything. It's just taking in something, doing something with it, and then it's done. And move's kind of a bad name. Maybe we should call it like update velocity using direction.
Oh, gosh.
We'll just make it really, really, really explicit.
Update velocity using direction. Let me think. What's velocity based on? So, by the way, we already have var direction up there and get move input. Is that using the same direction?
Ultimately, they're going to be the same direction.
That's just like kind of confusing. Am I crazy, or is like line 46 is when we define direction?
But it's scoped to this function.
It's scoped to that. Right. So we're technically defining it again at line 55, where we set the parameter being direction.
Correct.
That's where like it gets like a little, like they do the same thing.
Kinda, but you could technically take a direction from anywhere. So maybe you're not taking direction from a get move input function. For example, when we get to rolling, when your guy starts rolling, he's just going to go whatever direction he was facing. And you're going to move using that. You're not going to take the direction of the move input. So that's the difference. Is like this will take any direction. If you think of Vector 3 as like an arrow in 3D space.
So there's some things, some attributes. I don't want to use a technical term here. There's words that you'll use that are like, I imagine speed is another one that like in scopes you'll be defining speed for different things, and in your script there might be multiple different types of speed all named the same thing but in different parts of the script that are scoped to like speed only means this certain speed in this part because it's tabbed in, and then once we're out of it again and we're tabbed in again, speed can mean something else further down the script.
Yes.
Okay, I just wanted to prove to people that I frigging know what I'm talking about.
All right, so we're going to update velocity using direction. Heading back to idle player state. Oh, nope, sorry. Heading back to run player state. Even I get lost sometimes where I'm at. At this point, what we can do is now we can say player dot update using direction, and we'll just pass it direction here. This line's upset because global basis doesn't exist on base player state. And so all we have to do is say player.global basis. So that's going to get the player's global basis, which was just a fancy directional matrix thing. And then last lean was another variable or property that we made on player, which was whatever lean they had last frame. That way we could blend smoothly between the lean states of the player. So we will just say player.last lean. And we also need to do that here. So now that line is happy. And then this last one here is upset because last lean is, again, player.last lean.
See, I'm surprised that you are making it so we write player dot before these things. Like, is that how you would do it? Or is there a way to like, you could actually just reference instead of typing player dot after, like before all this stuff?
In this case, no. We have to use whatever name we gave to the parameter. So you could use P for all of these instead if you want to do something like this. And again, using Control or Command D to select all those. So you could do it like this, but this is less descriptive. That's why people don't really recommend doing single letter names.
Yep, I would undo that. Yep, thank you.
Yep. Okay, so we're going to head back to idle player state, and we kind of need to do the exact same thing for walking. So what we'll do is we will select this chunk of code, we'll cut it. We're going to do player change state to player states dot walk. Like that. We'll go to player states. We will add walk. And you can order these however you want. You don't have to order it like I do. We'll pull open the script. We need enter, player, void. We'll paste our code here so we can see what code we have. And again, this bit of code.
Let me guess. You're going to have to do like player.animtree.set.
Got it.
You're going to have to do player.animset again on line 8.
Yep.
And player.walkspeed?
No, walk speed's being defined here. This also needs to be done.
Speed?
we could do player.getCurrentSpeed.
Or was that fine the way it was?
No, that's what we needed to do. Okay. You're correct. Yeah. But we need to do this in update because we want to, this is like scaling the timing of the walk every frame. So we'll split this in half. Func update player, delta, float, void, ta-da. The other thing we need to do is we need to snag this bit of code right here, which is what's actually moving. This is moving the player, right? This update velocity, kind of. So we're going to do that and go to walk player state, and we'll do this. Okay. And then let's look back at
where
idle.
did we copy that from? What you just pasted?
Oh, I copied it from run player state.
Okay, gotcha.
So I just took that code and then reused it right here.
Cut it or copied it?
I copied it. We need it in both spots. Another thing I'm noticing, if we pop back to idle player state, is we have move and slide and we have turn to. And remember, move and slide is what actually causes the player to move. We could choose to have this be handled inside our update velocity. So we could change update velocity or whatever to basically just do the move and slide for us. We could choose to keep it separate, which sometimes can be useful. And then we also have the turn to, which needs the direction of like where we're turning the character. And we don't necessarily need to do all this work every frame. For example, if you're playing an animation where you're not turning and you're not moving, it's like, well, why would that state need to do those things? So we'll just keep it in the state machine so you can see exactly what each state is doing, and each state will be very clear on what they're doing.
So we're keeping, well, aren't we in idle player state right now?
So right now we're in idle. We're going to cut these two lines.
Yeah.
And we're also going to delete this current speed down here because we don't need it anymore. So we can delete everything below this. We'll save. Let's go to run player state. We'll do it in here. So we get our movement direction. We update our velocity using direction. Then what we'll do is we'll paste the thing we cut. I'm going to say player dot move and slide. Yeah. I'll do player dot turn 2. So that's going to turn the player.
Before you do that, by the way, what is the warning that you're getting on the red line? What does it say?
Basically, this warning is telling me there's no turn 2 function. And because we enabled the type safety features inside of Godot, it will yell at us about that. If you are not using those type safety features in Godot and you don't turn on the extra warnings and errors, it'll just silently act like everything's fine. It'll just be like, oh yeah, maybe that function's there somewhere and I don't see it.
Gotcha.
Yeah. Okay, so let's go ahead and we'll copy those two things we just did. We'll bring them back over to walk. So we have a very similar block of code here. And when you see blocks of code like this, you could turn this into a function that just does all these things for you. That way you don't have to redo it every single time. But that's entirely up to you. We're not going to do that here. We'll just keep it real simple.
As in continue to add it to each function.
Each function that needs it, or each state that needs it, I should say.
So idle doesn't need it because it doesn't move?
Idle doesn't need it because it doesn't move. Correct.
Even turn 2? Can't you turn when you're idling?
No, not in this game. Because the moment you start applying movement input, it's above 0.
You start walking?
Yeah. Just really slowly. And so the walking slowly
it looks better than being able to moonwalk, like turn, or moon idle turn.
Yeah. So let's see here. What else is left? A big one is applying gravity. So when you're falling, aka not on the floor, we need you to fall. So what we'll do is we'll cut this.
This makes me laugh about, real quick, before you delete that line. This is what makes me laugh about coding stuff. Like, I even said in my head, I was like, player is not on floor. And then I look at what it's actually typed at. If not, player is on floor. Or like, just like sounds the most inhuman. I feel like there's a way we could have switched words around to just make it like, if player is not on floor.
I mean, you could do if player is on floor.
Bang.
Equals false.
Yeah, exactly. No, other one's fine.
Well, we're going to get rid of it, so it doesn't matter. Because we're going to take this line, we're going to cut it, we'll delete this. And luckily, we have the fall player state, which is just kind of assuming you're falling, right? Like the moment you're in this state, we think you're falling. So we'll say func update player delta float void. And we'll paste that in there. And then we do need to say player dot move and slide, since that's the thing in character body 3D that causes your velocity to get taken into account and move. So we have to do that there.
I feel like we didn't have player dot move and slide on the last states. Am I wrong?
No, we did. We added those back in.
We did?
Right
okay,
here.
Sorry. No,
with that second block.
I thought it was just.
And
falling, we would have turn 2 as well, right?
Falling, you might have turn 2. Yeah, especially if you have some air control. So maybe what we do is we'll say var direction, and we'll say player get move input, and we'll say player dot turn to direction. All we're going to do when we're falling is we're going to fall straight down.
Yeah.
And we can turn, like we can rotate the guy when he's falling, but we can't move at all when we're falling. If we wanted, we could add in some custom velocity calculations here that would allow us to move. And then we could just use like a lower speed. So you can still have some air control, but not like a ton. Right now, our player dot update velocity using direction just takes direction, but it is actually using our speed property, which is set up here, no matter what. We might want to have the speed property be something we take in. So what we can do is we can actually say speed, and it's a float, and we can, to not break our existing code, we can assign a default value. We can actually set this to the speed property already on our player. But there's a problem. If I typed speed right here, trying to talk to this speed at the top, this one, it's not going to know that because it's going to think I'm talking about this.
Yeah.
So now I have this like cyclical dependency problem happening. So what we should do is we should actually call this our player's base speed. We'll come to the top and we will also rename this to base speed. And so now, if you don't pass me an explicit speed you want to use, as the second parameter, we'll use the base speed of the player. And so this speed represents base speed by default.
We literally are running into the issue that I was basically like almost getting to earlier when I was saying like things are named the same, but they're whatever. So like right here is an instance of like we almost use the same word in the same scope. Yeah. But because our one of the top, our variable speed needed to be something renamed so we could talk about the scope that we set in the function, which is just speed. Okay.
Yes. Go over to our fall player state And instead of moving like in the air as fast as we can move on the ground, we can actually just pass it a second parameter or second argument, and we'll say player.base speed, and we'll just times this by like 0.25. So you have a quarter of the air control when you're falling as you do on the ground.
Yep. This isn't Rocket League.
Yeah. And some games will have this be a thing where as you fall longer, you get less air control over time. We're going to keep it real simple to keep things moving. Let's go back to idle player state. Let's see if there's anything else. So the last thing we have is jump. And jump is a little tricky because jump is kind of tricky for a few different things, especially when you get into more advanced techniques like coyote time, which is where you kind of like run off a ledge a little bit and then jump.
And then you turn into a coyote.
And then the Roadrunner blows you up with dynamite.
Yeah. But it is named after that coyote runner thing, right? Because he runs off the ledge, and then it gives your player advantage, basically, when it comes to jumping off a ledge. It gives a little bit of grace where you can have an extra half second and then jump off of basically air.
Yeah, and we're going to actually get into some other similar techniques like input buffering when we get into combat, because that's an important part of like making your sword swings chain together and feel good.
Yep.
So where we're supposed to handle this in terms of a state machine can get a little weird because there's a lot of options. What might be the way to go is to use a transitional state representing jumping, and then all that state will do is immediately on the next frame go to falling. It'll kind of manage itself.
Because basically like jump is a transition almost. It's like your guy when he's jumping will look like he's falling.
Yeah.
Like his animation will look like it's falling.
Correct. But there's also things where like maybe you want to have it where you can hold the jump button to jump a little higher, so you keep adding velocity over time until you reach the apex and then you enter falling. So generally I use a state for entering a jump. So we'll just quickly come down here. We will make a script. We'll call it jump player state. Come down here. Extends base player state. Class name. Jump player state. Jump. And then we're going to give it an enter function. We will go back to idle. We will cut this part, because this is the part we care about right here. We'll add it here. And we need to say player dot. And we also need to say player dot jump velocity, since player has the jump velocity on them. And then immediately what we'll do is in pre-update, we will just switch right to player states dot fall. So we enter jumping state, we set our velocity, and then in the pre-update, before update runs, we'll just say, yep, go to the falling state.
Because we don't have our guy jumping animation right now. Our body is gonna launch into a fall state, basically.
Yeah.
That's jumping.
Yeah. Eventually what we could do is you could say like once the moment we hit the apex of the jump or something,
then you switch.
Then you switch. Yeah. But for now, we'll just set this up.
This and then this.
Yeah. All right. And then what we need to do is we'll take handling jump. And we don't need this part, the is on floor part, because we're going to add this at the end of this if chain. Because the first thing we check is whether or not we're not on the floor. We can just say elif input is action just pressed, UI accept. That's it. And we'll say player change state to player states jump. And we'll delete pretty much all of this for that state, for the idle state. And then let's make sure that this is in fact in player states. It's not. So add jump. So let's go ahead and I guess let's just give this a shot and see what happens if we hit play. See what breaks. Because typically when you refactor code, things break. And sure enough, something's broken.
We're definitely stuck in falling.
Yeah.
Because we're moving at a quarter of the speed.
Correct. And so
we're also falling.
And also we're falling. Yeah. But also look at how fast you can start to debug things when you know, hey, the falling state means I look like this, I'm in this animation.
So my guess would be that we aren't triggering the exit, to go to a walk or the next thing.
Correct. If we go to our fall player state, notice we have no transitions. There's no change state 2 happening here, right? Mm-hmm. We will go func pre-update, because that's where we're going to handle our transition checks. Player void, and all we need to do is say, hey, if player is on floor.
So we have to make this check in this state as well. Okay.
Yes.
Change
And we're gonna What state do you think we should go to next?
Probably idle, because idle will go to the next, like, walking or running quickly as well.
We do have a landing animation that we could trigger, and then after a second or so, go to the next state. But for now, I think this is probably fine. Just go to idle, and then idle can.
Do you want to see that immediately get fixed?
Yeah, let's see if this works. All right. So now the next thing is right now.
Can you still run around and stuff? Yeah.
Yeah, I can't run.
Okay.
So let's figure out what's broken there and debug that.
I imagine it's something with, like, there's something not transitioning back to, like, having control over your character.
Well, what it is a logic problem. So right here, see how we have the get current speed?
Yeah.
There's nothing that ever changes our player velocity to move in a non-falling direction. So there's never anything that's going to cause our speed to change.
In idle?
Right, in idle. There's nothing here that's going to check for movement. So what we can do is we can actually say, hey, let's go get our direction. Let's see if the player wants to move. So get move input. And we can use this instead of current speed. Because we can say, hey, if they're moving the stick around, they probably want to go somewhere.
Yeah.
And we could just say, instead of going directly to run from, if this is greater than whatever, let's just comment this out for just a second. And again, that was, for me, it's command/. If you're on Windows, control/. Let's just say if direction is greater than 0, or rather I should say if direction.length is greater than 0, so we have moved the stick some amount, we're going to go to the walk state.
I'm
then
just
what
trying
we'll
to
do,
see what the difference was between our last thing. Didn't we already have this, like, LF, like,
Yes, there's always some level of condition checking. It's just how much condition checking and how much happens in each condition directly.
Well, I'm just more of saying, like I feel like we already had the check in there to check if it was over 0, and then we would switch to player walk. So, like, what wasn't triggering?
Before it was triggering on current speed, because we would just say, hey, if you're not, if not on falling, and if this, then apply velocity, then move and slide. And so the velocity was changing. The character's velocity was changing. But right now, there's nothing that triggers a change in our character's velocity, ever. Because the walk and the run states are what take into account us wanting to move around. That's what actually updates our velocity.
It's too far away from what we changed it to. I don't even remember what we changed. Is it the length thing? Did we have a length before?
This is what we had before, current speed.
Okay, we didn't have a length.
Well, we had a length on, because if you look at where current speed was coming from, let's go back. If I was to hold command or control and click on current speed, it's getting the length of velocity. But velocity isn't ever changing beyond, it's always 0. Because we land on the ground, so we're not applying gravity velocity anymore, because the falling state does that. So the fact that there's nothing in idle state updating that's taking in our input and causing us to move means velocity never gets greater than 0. So there's no speed change. And if we base this on speed change, we're in trouble, because there's nothing to change the speed.
For the viewers,
so I just
that okay that I just gave, just you can classify that as Jack is still a little lost, but is going to push forward.
All right, so let's go ahead. Let's try playing the game now and see what happens. So now I can walk, but I can only walk, and I never get back to idle.
Even when you stop?
Even when I stop. I'm not moving, but my guy is walking slowly.
Yeah. Huh. So I think that it's missing the same thing for walk now to run.
Yes. Same thing for walk to run, and same thing back to idle. So if we go here, we're in walk right now.
Yep.
Let's add our pre-update. Player, void, and we'll say if, and here actually, before we do that, we'll say var current speed, because we can get whatever speed we're moving at right now. Because we are in walk, so therefore this set of functions right here, these two functions, these would change velocity. These would cause us to move around and have a speed. So if our current speed, for some reason, is now 0, and I'll go ahead and add a little space here just to separate it a bit, then we're going to say player change state to player states dot idle, and then we can also do the opposite of elif current speed is greater than player run speed, then player states dot run. All right, so does this make sense so far?
Yes, it's more than I expected to do. But yeah.
Yeah. Well, because, we get into a state, we have to say what are the ways we get out of the state.
Yeah, so exactly. So we're basically defining the slowdown and the speed up transition. Or like if we were to move faster, we're going to run. If we're stopping, we're going to idle.
All right. So let's go ahead and play this. And before I start moving our guy around, I want you to guess what's going to happen.
In a wrong way.
Maybe.
With what we just wrote, I think we're going to start running as soon as we start walking or moving. But you're not going to be able to come out of it.
You are correct.
Boom. And I totally said that because I thought about it, and that's just what my brain did. It didn't involve seeing you accidentally turn on your controller and start moving and reveal what was going to happen.
Whoops. Okay, so let's go to run state. Same thing. And we can actually just copy from walk real quick. And we don't need to worry about going to the run state. We just need to worry about when we fall below the run speed, then we go back to walk. All right, so let's go ahead and play that. So we have a bit of a harsh blend to work out.
I was going to say, are we able to even do like run to walk?
Right now, we always go through walk, but I think something is triggering it to be a little too aggressive.
You see what I'm saying? Like, it looks like you can go from walk to run, but not run to walk.
Yeah, well, I can do... That all looks good.
I'm saying, but yeah, once you're in run... Oh, yeah, you can go from run to walk.
Yeah. It's just when we stop, I think it's because we always pass through the walk for at least 0.4 seconds or whatever our default blend time was. And so it gives us this sort of like harsh juddering. Yeah. So what we could do is we could say, to get back to what we had before, we could say if current speed is 0, then we'll change state to player states idle. Elif. Otherwise, if the current run speed, or if the current speed is player.run speed, then we go to walk. There's less than whatever. You get it.
Yeah.
Huh. It's still very harsh. I don't know what's... Well, there it's fine. Oh, you know what it might be?
No.
Is it my stick is too sensitive on this computer? I think it's the stick snapping back is causing him to almost trigger the other... Yeah, he's flicking back the opposite way.
Like there's no dead zone on your controller?
Yeah. Yeah. So it looks like there's no dead zone on my controller, folks. That's why the animations sometimes look so rough when I do this. Okay, so this is already getting to be a really long episode. There was a lot to take in. We've refactored and changed a whole bunch of code, but we are now back to almost the state we were before.
Yeah, no pun intended.
Yeah.
Or pun intended.
Oh. You may notice that there's some states that aren't going to work exactly like they were before. For example, jumping isn't considered outside of the idle state. So your guys' homework is to figure out what you need to fix jumping when you're in the running and the walking states. I also would like to extend a challenge to you guys to try and implement a landing state that can actually play the landing animation. It's a very soft landing, and then go back to the idle state after the land is finished.
Cool.